Whiteboard animation A to Z. O-level math part 1. Topic 1 numbers, topic 2 square root and cube root, topic 3 direct numbers, Vulgar and decimal fraction and percentages, the four operation, the estimation, the limit of accuracy, the standard deviation, time, money and measures. These are the 9 topics that we are going to cover. Timelines is in the description. Ask me anything on the comment section. Part 2 and part 3 will come soon. Hello and welcome back. This is O-level math complete course, and in this video we are going to complete the whole course. We're going to divide it into three parts: part 1, part 2, and part 3. Okay, so there are at least 20 topics, and we're going to complete all these 9 topics will be covered in part 1, and then 6 topics will be covered in part 2, and then the remaining 3 topics will be covered in part 3. So let's start with topic 1, which is numbers. Okay, one thing to tell you guys, that let me tell you what kind of topics we are covering. So topic 1 is numbers and square root and cube root, direct numbers, Vulgar and decimal fraction, percentages, the four fraction, estimation, limit of accuracy, standard deviation, time, money and measures, indices and algebra, function notation and graphs, bearing, symmetry, sequences, statistics, set, language and notation, matrices, vector in 2 dimensions, and transformation. So let's start with topic 1. Let's start with part 1, and our first topic is numbers. So let's begin. Okay, so our topic 1 is numbers. Okay, numbers can be broken down into, let me write it down. Numbers can be broken down into imaginary numbers and real numbers. And real numbers can be broken down into irrational numbers and rational numbers. Okay, and then rational numbers can be further broken down into integers. Integers can be further broken down into whole numbers, and whole numbers can be broken down into natural numbers. Okay, so what is imaginary numbers? Imaginary numbers are those numbers which are not real, which are absolutely imaginary. We denoted these imaginary numbers as I, which is known as iota. And imaginary numbers are those numbers which are, under root square in negative number 1, let's say 1, or negative 2, or negative 25, minus. So any negative number in the under root square root is an imaginary numbers. Okay. What is a real number? Real numbers are those numbers which are real in the number line. What are irrational numbers? Irrational numbers are those numbers which cannot be written as a fraction form, as a simple fraction. For example, pi, e, under root square 2. These are all irrational numbers because they cannot be expressed in a simple fraction. Rational numbers, on the other hand, can be expressed in simple fraction. For example, 5 upon 1, 2 upon 5, 25 upon 7. So these are all rational numbers. Okay, it could be even minus 3 upon 4. This is also rational numbers. Okay, all integers are can be, rational numbers can be made by integers. Okay, so what are integers? Integers are those numbers which have a negative numbers and positive number. Let's say minus 3, minus 2, minus 1, 0, 1, 2, 3. So these are all integers, including positive numbers and negative numbers. What are whole numbers? Whole numbers are those numbers which include 0, 1, 2, 3, 4, 5, but it doesn't include negative numbers. Watch out, our natural numbers. Natural numbers are just counting numbers, 1, 2, 3, 4, 5, but excluding 0. Okay, we do not put 0 in natural numbers. 0 can only be found in whole numbers. Okay, so this is what a number really represents. This is what a number really is. Now we're going to move on to square numbers and cube numbers. Okay, square numbers and cube numbers. Square numbers, let's say that I have number 2. We're going to square it by 2, and then it will give 4, which means 2 multiplied by 2 is equals to 4. 3 multiplied by 3 is equals to 9, which is you can written as 3 of power 2. 4 multiplied by 4 is equals to 16, which you can write it down as 4 of power 2. So square numbers. 6 multiplied by 6 is 36. 7 multiplied by 7, 49. 8 multiplied by 8, and alright, so these are square numbers. And cube numbers are those numbers which you put a power of 3 in any number. So if 2 of power 3, that means 2 is multiplied 3 times. 8. If you put 3 of power 3, then it's going to be 3 multiplied 3 times. Okay, by itself. So 27. Let's say power 3. Then 4 multiplied by 4 multiplied by 4. 4 4 is 16, 64 is 64. Okay, so these are all cube numbers. What are factors? Okay, now we're going to understand what are factors. factors, let's say that I want to know the factor of 8. Okay, so 8 can have a factor of 2, it can have a factor of 1, it can have a factor of 4, it can have a factor of itself 8. So factors are just, whenever we try to divide this, let's say 8 and 2, then it's going to be, okay, factors are those numbers which does not give a remainder, does not give a remainder. So we can say that it's a factor of 8. So 2 can be a factor of 8, 1 can be a factor of 8, 4 can be a factor of 8, 8 can be a factor of itself. We can also write it down in this way as well. Let's say 2 multiplied by 4 is equals to 8, or 4 multiplied by 2 is equals to 8. These two are factors of 8. Okay, it could be 1 multiplied by 8 is equals to 8, or 8 multiplied by 1 is equals to 8. These two numbers are also factors. Okay, so these are all factors. Moving on to multiples. What is multiples? Multiples is, multiplication. Let's say that I want to know the multiplication of 3. So 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, and so on. So this is a multiple of 3. Let's say I want to know the multiple of 5. 5 1s are 5, 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25, and so on. So this is a multiple of 5. Okay, so we have understood it. Now what is composite number? Composite number are those numbers which have a factor more than 1 and itself. So let's say 8 is a composite number because it has factors of more than 1 itself. It has a factor of more than 1. It has a factor having, it has one more factor other than 1 and itself. So these are extra factors. So which means this is a composite function. Okay. Let's say I want to know whether 16 is a composite function or not, and I will say yes, because other than 1 and itself, it has a factor of 2, because 2 can be easily divided to 16. To 8 is 16, which means 8 is also a factor of 16, and it can also be 4 as well. 4 is a factor of 16. 4 is 16. Okay, so having only having one more factor than other than 1 and itself is known as a composite number. Okay, so what is a prime numbers? Prime number. Prime numbers are those numbers which only have two factors, 1 and itself. So let's say 2 is a prime factor because 2 has a factor of 1 and itself. It doesn't have any other factors. So I can say that this is a factor. Okay. 3 is a factor. 3 is a prime number. I can say that 2 is a prime number. Okay. 3 is a prime number because it has 1 and itself as factors. 5 is a prime number. It has a 1 and itself as 5. Okay. 7 is a prime number because it has 1 and itself of factors. Okay. But what if I say 9 is a prime number? No, because it has 1 and 9, but also it got 3. So prime number is so 9 is not a prime number. Okay. So we can keep on going like this. Oh, okay. One thing to remember that 1 is not a prime number. 1 is not a prime number. Okay. So we're going to start like this: 2, 3, 5, 7, 11, 13, 17, 19. So these are all numbers which have a factor of 1 and itself. Okay. So this is a prime number. Prime factors. What we know what is factors, right? Let's say I have 48 and I want to break it down into its factors. I'm going to break it down. I'm going to use a tree diagram to break it. So if I try to break it like this, let's say if I want to divide this number by 2, so 2 2s are 4, 4 is 8, so it's going to be 2 in here, and 2 2s are 4, 4 is 8, 24. Now I'm going to divide. I'm going to break down 24 as well. Divide this number by 2, so 2 1s are 2, 2 12. Again, break it down. Divide this number by 2 or 3, 2 and 6. Then again break it down. Divide this number by 2, and then you get 3. Okay. So I just got its its prime number. See this? You can break it down. 48 is equals to 2 multiply by 2 multiply by 2 multiply by 2 and multiply by 3. So these are all prime factors because they are prime and they are factors. When you're going to multiply all of these, then it will give 48. Okay. And these are composite factors. These are composite numbers. Okay. Now let's move on to HCF and LCM. HCF stands for highest common factor. Stand for least common multiple. Okay. So let's say that I want to know the HCF of 25. Find the HCF of 24 and 36. Okay, so what is HCF basically? Actually, when we have any two numbers, let's say we have 24 and 36, and then we're going to break it down into its factors. First of all, we're going to break it down into its factors, and then we're going to compare it. We're going to take a common between the we're going to take a common of the factors between these two numbers, and we're going to see that which of the factor is highest and common between these two numbers. This is HCF. Highest, it is common, and it is also a factor. So it must be a factor between the and it must be common, and more importantly, it must be highest. So highest common factor. Okay, so let me just get the factors of each number. Let's say I want to know what are the factors of 24. We're going to break it down. 24. So I'll start with 2. Once the 2, 2 to the 4, then again 2, 6, then 2, 3, and then 3 once. So to 12, 24, and then right here to 6 at 12, then again we 2 to 3 to 6, and then 3 once at 3. So we have breaking down 24 into its factors, which is 2 multiplied by 2 multiplied by 2 multiplied by 3. So these are all factors of 24, and if you try to multiply all of it, then it will give back 24. Okay. And now I want to break it down 36 as well, the same thing that I just did to 24. So I'm going to divide this number. I'm first of all always try to divide any number by the smallest number. So the smallest possible number can be 2 and 3, but I'll start with 2. So 2 ones are 2, 8 is 16, then 2 9s are 18. Then now we cannot divide this number by 2, so we're going to divide this number by 3. 3 6 are 9, 3 1s are 3. So we have got this factors of 36. So 36 is equals to 2 multiplied by 2 multiplied by 3 multiplied by 3. These are all factors of 36, and now we're going to take a common. So right here you can see that 2, 2 and 3 are common in both the numbers. And if you want, we can just make it more simpler. 2 to the 4 is 12. So 12 in here and 12 in here. So these two numbers, the 12 is a highest common factor. So it is highest, it has a common, and it is a factor. So HCF is equals to 12. Highest common factor between the two numbers. This is what HCF really is. This is how you find HCF. Now let's say I want to take the LCM, least common multiple. What is least common multiple? So let's begin with the question. Okay, let's say it has been asked that find the LCM. Find the LCM of 63, 80, and 102. So these are all three numbers, and we need to find the least common multiple of 63, 80, and 102. Least common multiple. Okay. We need to find a multiple which is a common, and it is a least common multiple. A multiple which can come in the table of 63, 80, and 102. Okay. This is what actually a least common multiple really means. Okay. So how to find the least common multiple? Again, we're going to break each number into its fraction form, into its factors, not fraction form, sorry. Okay. 63. Let me say, we cannot divide this number by 2, as you can see for yourself, but 3 might be a possible value to divide this number. So 3 2s are 6, 3 1s are 3, 3 8s are 24, or no, 3 7s are 21, so, and 7 1s are 7. Okay, we have break it down. Now we're going to break down 80 as well. So 80, now divide this number by 2, 40, again 2, 20, again 2, again 2, and then 5. Okay, break it down. Now we're going to break down 102. So 2, then 2 5 the 10, 2 5 the 10, 2 1s are 2, again 2, or maybe 3 1s are 3, then it's going to be 21, so 3 7s are 21. Okay, and then 17 1s are 17. Okay, we have break it down all these numbers. Okay, we have break it down. Now what we're going to do is, the method which I'm going to show you guys is a little bit tricky, but you need to remember it and how to take the LCM of any numbers. Okay, so what we're going to do is we're going to write down like this. Okay, so 63 have 3 of power 2. Okay, so 3 multiplied by 3, which means 3 of power 2. 3 is multiplied 2 times, or by itself. We can do the same for this one. It has 4 2, so 2 of power 4 multiplied by 5. We have 102, so yeah, it doesn't have much simplification. What we're going to do is we're going to write them in a row, in a sequence. So 80, 2 of power 4 multiplied by 5, then 63, 3 of power 2 multiplied by 7, and 102, 2 multiplied by 3 and multiplied by 17. Now take the highest number. So I can see here that 2 is the highest number. 2 is the highest number, so we're going to write 2 of power 4. 5 is the highest number, it doesn't have any, there's no 5, so we're going to write 5 down here. 3 is the highest number in the row, so 3 is power 2. 7 is the highest, 7, and 17, 17. Okay, and so now if we try to multiply this, let me use a calculator. 5,680. So this is the LCM of these three numbers. This is the LCM of these three numbers. This is LCM. This is how you take the LCM of any number. So what is LCM? Basically, let's say that I have a multiple of 3, yeah, 0, 3, 6, 9, 12, 15, 18, 21. Let's say 21. 24, 27, and let's say I have a multiple of 5 or multiple of 4. Okay, let's say I have a multiple of 4, so it's again 0, 4, 8, 12, 16, 20, 24, 20, and etc. So let's and now I want to find the LCM between the of these two numbers. LCM, least, first of all, it's a multiple. Okay, it's a multiple, it's a common, and it must be a least one. So least common multiple, multiple, common, and least. Okay, so right here I can see that 0, oh, no, or maybe not 0, 12 is the least common multiple. 12 is the LCM of 3 and 4. Okay, so 3, if I try to take a factor of 3, so 3 have a factor of itself. 3 ones are 3, 3, and 4 is a factor of 4. And if you try to take the LCM, then 3 will be here, 4 will be here, and 3 multiplied by 4 is equals to 12 is the LCM. Okay, so this is topic 1, numbers. The topic is completed, and just so you know, this is how you take the LCM. Okay, first of all, you take all the factors. When once you take all the factors, you're going to write it down like this, write it down in a row. Then you're going to compare that which number is the highest. You can see the 2 of power 4 is the highest number, so you're going to write it down. Then you're going to compare all the 5 values. So there are no 5, only this 5, so 5 will come down. Then you're going to compare between 3 of power 2 is the highest number, so it will come down. 7, and there are no 7, only this one, so 7 will come down and 17 will come down, and then you just multiply all of these numbers, and then you will find the LCM. The LCM of 63, 80, and 102. Okay, so topic 1 number is completed. Now we're going to move to topic 2, square roots and cube roots. Okay, so topic 2 is square roots and cube roots. Okay, so whenever we try to take a square roots of any number, let's say, before moving on, understanding square root and cube roots, let's say that 2 multiplied by 2 is equals to 4. These two numbers are positive and they're both multiplying. 2 multiplied by 2 is equals to 4. And if we try to multiply minus 2 multiplied by minus 2, then again it's going to be 4. Okay, because minus is plus. We can understand this in a moving. Okay, plus is plus, minus is plus. So, but if we try to take a square root of this number 4, then it's going to give two possible values. Okay, it could give minus 2 and it could give plus 2. So that's how we write whenever we try to take a square roots of any number. Let's say if I want to take the square root of 9, so it's going to be positive minus 3. Okay, which means it could be positive 3 and it could be minus 3, because if I try to multiply 3 multiply by 3, it's going to be 9. If I try to multiply minus 3 multiply minus 3, then again it's going to be 9. Okay, so this is the story of square roots. But cube root is a different thing. Cube roots, let's say if you try to multiplying 3 times, 2 multiply by 2 multiply by 2, and these two, all these 3 2 are all the 2's are positive. So 2 multiply by 2, so it's going to be positive 8. And if I try to multiply minus 2 multiply by minus 2 and multiply by minus 2, then again, but it's a different situation. It's going to be minus 8, because minus is plus positive 4 multiplied by minus 2, and plus minus is minus 8. Okay, so it's a different story for cube roots, and it's a different story for square roots. Whenever we try to do the square roots of any number, it will give two possible values. Okay, it will give two possible values, plus and minus. But if we try to take a cube root of any number, let's say if I want to take the cube root of a, then it will give me 2. And if I try to take the cube root of minus a, then it will give minus 2. So it's a one possible value for cube roots. Okay, two possible value for the square roots, one possible value for the cube roots. So topic 2 is done. We will start with directed numbers. And what is a directed number? So let's say that we have an object A and we need to find the temperature. Okay, so what is the change in temperature of object A. Okay, so the initial temperature was minus 2 degrees Celsius, and the final temperature was 9 degrees Celsius, or maybe 7 degrees Celsius. Okay, and now I want to know what is the change in temperature of object A. So what I'm going to take, so the answer should be, change in temperature is equals to final minus initial. So final minus initial. In final you have 7 degrees Celsius, and in initial you have minus 2 degrees Celsius. So 7 minus is plus, so 7 plus 2, and now it's going to be 9. So the change in temperature is 9 degrees Celsius. This is directed number. So let's start with the fraction. What is a fraction? Fraction can be written in the form a upon b. Okay, so this whole thing is a fraction. A is known as the numerator, and the downside is known as the denominator, and this whole thing is known as a fraction. Okay, so there are two types of fractions. Improper, you can for example, proper fractions, improper fractions, and and you can convert improper fraction into mixed number. Okay. So what is a proper fraction? Proper fraction is, let's say that proper proper fraction is 4 upon 7. Giving an example, let's say that I have a circle and I want to divide the circle into 7 pieces. So 1 2 3 4 5, 1 2 3 4 5 6, and then if I try to divide this more, now I got 7 pieces and it says 4, so I'm going to fill out 4 2 3 4, so it's going to be 4 upon 7. This is how you use fraction. Let's say, take this as a pizza. You took 3 slices and 4 are remaining, so 4 upon 7. If you want to write the fraction for that, how many how many has been eaten, then you can write it down as 3 upon 7, because 3 are empty, 4 remains. And what are improper fractions? Improper fractions is when a numerator is greater than the denominator. Let's say, so 7 upon 4. This is known as improper fraction. And then you can convert this improper fraction into a mixed number. Let's say that I want to take the division. 7 and 4. 4 1 is 7. Okay, not 7. 4. This is 1. And 3. 3 is a remainder. You can write this down as 4, 1, and 3. 3 is a remainder. 4 1 is 4, and 3. This is a mixed number. This is how you write it down as mixed number. And if you want to convert the mixed number back to improper fraction, what you're going to do is, let's say that I have this and I want to convert it back. So first of all, 4, it's going to multiply by 1, and then it's going to add it to 3. So 4 1s are 4 and plus 3, so it's going to be again 7 upon 4. This is how you write it down back. Okay, improper fraction, proper fraction, mixed number. Now what happens if someone asks you about find the fraction in simplest form, So what we're going to do is, let's say that we have a number 4 upon 16, and it has been said, and it's saying to you that find the fraction in simplest form. What is the simplest form? So right now you can see here that this fraction is not in its simplest form. We need to make it in its simplest form, and in order to do that, we are going to cancel out the, what we're going to do is, let's say, dividing these, the numerator and denominator by the common number, by the number that these two can be divided. Let's say I'm going to use 2. So 4 can be divided by 2, and 16 can be divided by 2 at the same time. So if I use 2, then 2 2 is a 4, and 2 8 is a 16. Okay, so this is how you try to simplify it. Okay, you choose a number which can divide the numerator and denominator at the same time. Okay, right now I just choose 2. So 2 is dividing the numerator and denominator at the same time. Now I can divide this again, because 2 can be divided by 2 and 8 can be divided by 2. So 2 1s are 2, 2 4s are 8, and 1 upon 4 is its simplest form, because it cannot be divisible further, both denominator and numerator at the same time. Let's say that we have 9 upon 27. I want to know that I'm going to use a number which can divide numerator and denominator at the same time. So if I can use 3, then 3 3s are 9, and 3 9s are 27. Again by 3, it can be divisible by 3. Again, 3 1s are 3, 3 3s are 9. So 1 upon 3 is its simplest form. Okay, let's say if I want to know what is the simplest form of 25 upon 100. I can see here that 5 can divide 25 and 100 can both be divisible by 5. So I'm going to do that. So 5 5s are 25, and 5 2s are 5 20s are 100. Again by 5 1s are, and 5 4s are. It cannot be divisible further now. So 1 upon 4 is the simplest form. So this is how you find the simplest form of any fraction, where the denominator and numerator can be divisible by a number. Okay, this is how you find the simplest form. Okay, now what is percentage, decimal, and what is the relationship between percentage, fraction, and decimal? Let's say that we have a percentage. Okay, you know what? I can convert any fraction into decimal form and in percentage form as well, So fraction, decimal form, and percentage, all are the same thing, connected to one another. You can just for example, let's say that I have a percentage 75%. 75%, and percent means divided by 100. That's what it means. So 75% can be converted into 75 upon 100. Okay, now if I want to, so this is a fraction. I can simplify it. You can find it in simplest form. If I see that 5 can be divisible in both the denominator and numerator, so 5 20s are 100, and 5 1s are 5, 5 5s are 25, 15. Again by 5, so 5 3s are, 5 4s are. So 3 upon 4 is the simplest fraction. So percentage is converted into fraction, and if I wanted to, I can convert this fraction into decimal as well. Okay, so 4 3 3 1s of 3, 1 point 0, 3 3s are 9, 9 1. Then again, so it's going to be 3 3 3. So that in decimal form it's going to be 0.333. Okay. Percentage, fraction, decimal, all are connected to one another. Okay, Let's say if I want to know, let's say if I wanted to convert the fraction into percentage. Let's say if I wanted to convert this into percentage. How on earth am I going to do that? I'm going to multiply this by 100. So it's going to be 2 to the 4, to 5 the 10, and 3 5 the 150, and 150 can be divided by, so it's going to be 75. And we're going to write it down like 75%. Okay, we have converted this. We can also write it down 3 upon 4 as a fraction form as well, just like I show you that 1.33. This is the decimal form, this is the fraction form, and fraction form can be converted into percentage by multiplying by 100. So this is the the relationship, percentage, fraction, and decimal form. Okay, and this is the end of topic 4, vulgar and decimal fraction and percentages. Topic 5, the 4 operations. So let's begin. So we have 2 integers, and what happens if 2 of them have different sign, plus minus, and between plus minus, addition, subtraction, multiplication, and division, what happens? We need to find the conclusion in these. Okay, right now you can see here that this is positive 5 and this is positive 5 and this is negative 7. What happens if there is addition? If there is addition between these two numbers, then we need to remember that plus minus is minus. So 5 minus 7 is equal to minus 2. So again, positive 5 minus 7, and there is subtraction. Okay, subtraction. So there is subtraction, 5 minus minus 7. So minus minus is plus. So 5 plus 7 is equal to 12. Again, okay, so these are these two numbers, two negative numbers, and there's a multiplication. Again, minus minus is plus, so 14. Now two numbers, 2 is positive and 7 is negative, minus 7. And again there is multiplication. Multiplication plus minus is minus, so minus 14. Now there is division in these two. The first one is minus 15 and minus 3, there's a division. So minus minus is plus, or you can just say that minus minus cancel out, because we can write it down in like this as well. 15 minus 1 multiplied by 3, so minus 1 is cancel out, leaving only 15 upon 3. So minus minus is plus, so 5. Again, minus 15 upon 3, so minus 15 upon 3. So plus minus is minus, so minus 5. Okay, this is how you remember. And now you have found the conclusion that minus minus is plus, plus minus is minus, plus plus is plus, and minus plus is minus. Okay, this is the conclusion. You need to remember it. It's very easy. So this is the conclusion. Okay, this one and this one is the same thing. Minus minus is plus, and plus plus is plus. Plus minus is minus, plus minus is minus. Okay. Okay, now we have order of operations. So order of operation, or you can just say board mass. First there is brackets, so B comes in brackets, then come division. First come brackets. Brackets come first whenever we try to solve the equation. Then comes multiplication or division. Okay, multiplication or division, and then comes addition and subtraction. This is how you need to remember it. Okay, so bracket comes first. These are the brackets. First come this type of bracket, then comes this type of bracket, and then comes this type of bracket. Okay, then come multiplication or division, and then addition or subtraction. Okay, right now let's say that we have this equation and we need to solve this equation. Okay, so I'm just going to solve this. So 2 plus multiplied by 4 divided by 5 plus 3 power 2. Write it down. 6 multiplied by 4 upon 5 plus 3 of power 2. So 6 4 is 24. So it's going to be 24 upon 5 plus 3. 5 plus 3 is 8. 8 power 2. So 8 is 64. And then we're going to take the LCM. So 64 is multiplied by 2, which means it's going to be 128 plus 24 upon 64. Okay, 128 plus 24 upon 64, and it's going to be 19 upon 8 as an answer. Okay, let's move on. Okay, integers. So we have integers, and what happens if we try to divide it or multiplying it? And the methods of multiplying integers is number 1 long multiplication, number 2 binomial expansion, and the method of dividing is number 1 long division, and number 2 chunking. Chunking is not that amazing. Long division is awesome, binomial expansion is awesome, and long multiplication is awesome, but we're going to learn chunking as anyway. Extra knowledge is good for you. Okay, let's say that we have the question that work out 352 multiplied by 47. So 352 multiplied by 47. So let's start with long multiplication. So 352 multiplied by 47. Okay, 7 2s are 14. Carry 1. 7 5 is 35. So 36. 3 is up. 7 3 is 21. 22 20 24. Okay. Now the second row. 4 2s are 8. 4 5 is 20. 2 is up. 4 3s are 12. 13 14. Okay. 4 9 10 4. 1 is up. 5 6 and 1. This is how you do long multiplication. And yes, this is the answer. Okay. Now let's see with binomial expansion. Again, work out 352 multiplied by 47. So I could just write it down like this: 300 plus 50 plus 2 multiplied by 40 plus 7. Okay. So now, and then I'm going to multiply each one to this, to this, to this. And then 7, doing the same thing with 7 as well. So 4 3s are 12, 0 0 0 plus 4 5s are 20, 20 0 0, 4 2s are 8, 80. Now with 7, 7 3s are 21, 0 0, 7 5s are 35, 0, 7 2s are 14. Okay, now we're going to add it up. I'm using my calculator, or maybe not using a calculator. You need to do it without the calculator. So 1200, 2000, 80, alright, 2100, 350, and 14. Okay, now add it up. 4 and then 6, so it's going to be 4, it's going to be 14. Okay, 4 5, then it's going to be 6, and it's going to be 1. So there you go, the answer is correct. This is how you do binomial expansion, this is how you do multiplying, but I would prefer long multiplication. I would prefer both of them are correct. Okay, now let's start with dividing long division. So let's say that we have to work out with 816 divided by 34. So long division looks something like this. 34, now 34 2s are 68, then it will come 13, 6 will come down, 136, then 34 4s is 136. Okay, there you go, this is how you do long division. Okay, 136 upon 136 is equals to 136 cancel out, so this is long division. Now let's do the chunking. So chunking looks something like 816, and let's say 30 for 30, 816 must be divided by 34. What happens if we 34 multiplied by 10? So it's going to be 340. Okay, so 816 340 minus it, then you'll get 476. Write it down in the bracket. 34 multiplied by 10, then again 34 multiplied by 34 multiplied by 10, 340 minus, and then it's going to be 136. Okay, 34 is multiplied by 4, so it's going to be 136. Cancel. So if you make a total, then it's actually 24. The quotient is 24. Okay, so this is how you do chunking, but long division is much simpler and easier for you guys to use it. So I would prefer long division in dividing. Okay, integers done. So let's say that we have to work out 4.36 multiplied by 0.52. Okay, so what we're going to do, 4.36 multiplied by 0.52. We know that if the points go this side, then it will come down to 436 upon 100. Multiply, if the point comes this side, then it's going to be 52 upon 100. Now 436 multiplied by 52. 6 2s are 12, 3 2s are 6, 7 2 4s are 8, 5 6 are 30, 3 is 5 6 are 15, 16 17 18, 1 5 4 are 20, 21. So 2 7 6 1 2 2 2 2 6 7 2 is the answer. So 2 2 6 7 2 upon 1000. So 1 2 3 4, 1 2 3 4. Okay, so the answer is 2.2672. Okay, this is multiplying. Now let's look for dividing. Let's say that we have to work out 25.7 upon 0.08. So now what we're going to do is 25.7. Okay, I didn't tell you guys that if we do the reciprocal, something that is divisible, let's say 0.8, if we try to make a reciprocal to multiplying, then it will be 1 upon 0.8. Okay, something like that. Yeah. Okay, so if I do the reciprocal, then it would look something like this. Now if I try to putting the decimal point, so it's going to be 0.10 if the point go this side, and if the point go this side, so 100 upon 8. Yeah, so 100 upon 8. If I try to simplify, to 4 are 8, to 5 are 10. Okay, and 0 0 is cancelled out, and if I try to multiply, 257, 5, 7 5 are 35, 3 are 5 are 25, 26 27 28, 5 2 are 10, 12. So 1285 upon 4. Okay, it will give what? Doing the division, 1285, 4. 4 3 are 12. Okay, 0, 8 comes down, 4 2 are 8. Okay, 5 comes down, 4 1s are 4, 4 1, then put a point, then 4 2s are 8, 2, put a point, 20, then 4 5s are 20. So this is the answer, 321.25. Okay, so this is the answer, 321.25. This is how you divide. Decimal for the multiplication, division, and division for decimal is done. Adding and subtracting fractions. So right in front of you guys we have two boxes, and if you try to count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 boxes. So 20 and 5 are filled. 5 on the 5, 5 for the 20. So it's 1 upon 4 for this one. And for this 4 boxes, so 5 4 is 20. Again, it's 20 boxes, but this time there are at least 8. So 2 4s are 2 tens are, 2 twos are, 2 fives are. So 2 upon 5 is this one. And taking the addition, we need to use the LCM for the denominator. So 1 upon 4 multiplied by 5 plus 2 upon 4 multiplied by 4 multiplied by 4. Okay. Then it's going to be 5 plus 8 upon 20. Then it's going to be 13 upon 20. Okay. Just like that. Same applies for subtracting fractions. We always fractions. So let's say that this is 1 upon 4. This is 4, this is a whole box and it divided into 4 and one of them is filled, so 1 upon 4. Okay. What happens if we try to multiply 1 upon 4 by 1 upon 3? Then it will give 1 upon 2. What does this mean? It means that there are 12, there are 12 divisions inside a box. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12. 12. And one of them is filled. So right here, this one is filled. This is what it really means. And this is how you do the multiplication. Okay. But what happens if we try to divide something? Let's say 4 upon 4 is multiplied by, or wait, let's say 4 is divided by 2 upon 3. How are we going to do this? We can just simply, reciprocal the, we can just do reciprocal, like, multiplication then 3 upon 2. First it was 4 divided by 2 upon 3. If you try to reciprocal the sign to multiplication, then it's going to be 3 upon 2. And so 4 3s are 12, 2, and then 6. Okay? Topic 5, the 4 operation is done. That's all we need to remember. Now we are moving to topic 6, estimation. 6, which is estimation. Okay, this topic we are going to understand about rounding. What are decimal places? And what is significant figures? So let's start with rounding. If the number is greater than 5, let's say that we have 45. We're going to see this one. If number is greater than 5, then it will round up. So it's going to be 50. But if number is less than 5, it will round down. So it's going to be 40. This is what rounding really means. So let's say that we have the number 4827. Okay, and let's say that we want to round it to the nearest 10. So if we try to round it up to the nearest 10, then it's going to be 430. If you want to round it up to the nearest 100, then it's nearest 100, then it's going to be 4800. If it needs to be rounded to the nearest 1000, then it's going to be 5000. Okay, so again, nearest 10, which means you can see the 7 is greater than 5, so round it up to 30. Then the nearest 100, 2 is less than 5, so it's going to be 4800. Okay, now you can see for the nearest 1000, you can see 8 is greater than 5, so it's going to be 5000. Round it up to 5000. This is what rounding actually means. Again, let's say that I have 34 and I want to round it up to the nearest 10, then it's going to be 30. Let's say that I have 6809 and I want to round it up to the nearest 100, so it's going to be 6800. Let's say that I have the number 1951 and I want to round it to the nearest 1000, so it's going to be 2000. So rounding fraction work exactly the same way as rounding whole numbers. The only difference is that instead of rounding up to 10, 100, and 1000 and so on, you round to 10, 100, and 1000 and so on. I mean, let's say that I have the number 7.199 and I've been asked to round it up to the nearest 10th. So it's going to be 7.8. Okay, let me make you guys clear. Let's say 0.000000. This is a decimal point. Okay, this is 1000. This is 100. This is 10th. This is ones. This is 10th. This is 100th. This is 1000th. Okay, see the difference? There's 100 and there's 100th. Okay, 100 and 100. That's the difference. Okay, so we can do the rounding stuff. From 1000 to 1000th. So let's say that I have the number 7.8199 and I want to round it to the nearest 10th. I mean this, to the nearest 10th. This one to the nearest 10th, which means this one. So if I want to round it up, I will see this number, and this is less than 5, so it's going to be 7.8. Let's say I have the number 1.0621 and I have to round it up to the nearest 100th. 100 means this number. I will see this number and it's less than 5, so it's going to be 1.0. This is how you round it up. This is what we call rounding. Okay. Now we are going to move forward for decimal places. So we have understood what is rounding. Now decimal places. What is decimal places? Decimal places, for example, let's say that I have the number 7.864 and I want to convert it to 1 decimal places. Okay, so in order to convert to 1 decimal place, which means there are number of three, there are three decimals, and I want to convert to 1 decimal place. And in order to do that, I will do the rounding. So I will round to the nearest tenth. So it's going to be 7.9, and this point is 1 decimal places. Okay, let's say that I have the number 5.573 and I have to do it to 2 decimal places. So I'm going to round it up this one, and I'm going to see this. So it's going to be 5.57. Let's say that I have the number 68.1572 to 3 decimal places. Okay, so 3 decimal places, which means this one, and I'm going to, I need to round this one, and I will see this one. So it's going to be 68.157. So 3 decimal places. Okay, this is what decimal places really means. Now significant figures. Significant figures are numbers that can be approximated to given, numbers can be approximated to given number of significant figures. I mean, let's say that I have the number 2, 3, 4, 7. So how many significant numbers are there? There are 4 significant figures, 4. But 0 is not counted. Let's say that I have the number 2, 3, 6, 0, 0, 0. How many significant numbers are there? There are 3 significant figures, but these zeros are not counted. Okay, let's say that I have the number 0, 2, 0, 0. How many significant figures are there? There are 3 significant figures with 0 in between these two numbers. So yes, we're going to count that as 3 significant figures, but these two zeros are not counted. This is how you find the significant figures. Okay, and what happens if there's a decimal point at the end? Zeros can be counted. So numbers with decimal points. 40, 0.0. How many significant figures are there? Okay, now you can see since there's a decimal point, so we're going to consider all of these 4. So there are 4 significant figures. Okay, if the number is 0.5, then again there's 5 significant figures. Okay, but if the number is 0.000600, so what are the significant figures? We always see the number first. So in right here there is 3 significant figures, and the left side 0 are not counted. Okay, this is how you find the significant figures when having a decimal point number. Okay, let's say that you want to convert the number into let's say that you've been asked that write 1518.23 769 to 2 significant figures. So it's saying that we have to convert to 2 significant figures. So we're going to round it up this one. We're going to round up this one, and we're going to see this. Okay, so 8 is greater than 5. I mean, when we round it up, so it's going to be 1, 6, and 0, 0, 0, 0, 0. So this is 2 significant figures. So rounding is very important in finding the decimal places and finding the significant figures. Okay, let's say here that you have been given the number 43.25, and we need to do this to 3 significant figures. So which means we're going to round up this one. We're going to see this number is greater than or equal to 5. So it's going to be 43.3, which is the 3 significant figures. But 0.0043, and we need to convert this to 1 significant figures. So right now you can see that these zeros are not counted. We are going to count these are 2 significant figures. So we're going to round it up this one. So it's going to be 0.0040. So this is going to write 0 in here because it would be considered as 2 significant figures. So 0.004, which is 1 significant figures. Okay, so what is the difference between decimal point and significant figures? The total number of digits to the right of the point are known as decimal point, whereas significant figures start from the first non-zero number. So it starts from the first non-zero number, any number which is non-zero, then it starts from there. So these are significant figures. Okay, number 273.245, and I want to convert this to 2 decimal place and 2 significant figures. Okay, so 2 decimal place, which means I'm going to round it up this one. So it's going to be 273.25, since this 5 is greater than or equal to 5. And as for 2 significant figure, I'm going to round it up this one. Okay, so it's going to be 27.000, or I'm not going to round 0 at all because it would be considered a significant figure. So this is the 2 significant figure excluding 0. Okay, now let's do the exam questions. Suppose that we have been given a question that by writing each number correct to 1 significant figures, estimate the value of 48.9 multiplied by 0.207 square upon 3.94. Okay, by writing each number correct to one significant figure. So first of all, we're going to convert each number to one significant figure, and then we're going to find the value. Okay, so let's start with this one. How to convert this to one significant figure? We're going to round it up this one. So it's going to be 50. How to convert this number to one significant figures? We're going to round up this one too. So it's going to be 0.2. That's it. Okay, how to convert this to one significant? We're going to round it up this one. So it's going to be 4. So 50 multiplied by 0.2 multiplied by 0.2 is 0.2 multiplied by 0.2, so 2 upon 10 multiplied by 2 upon 10, 40 upon 100, 0 point, or maybe not. Okay, it's not going to be, okay, so it's actually, so 4 upon 100, so it's going to be 0.04, so 0.04 upon 4, and the answer is, so 50 multiplied by 4 upon 100, cancel, 5 4s are 20, and 0. Okay, 5 4s are 20, so 2 upon 4, 0.5 is the answer. Okay, this is estimation. Now we are going to move to the next topic, pound, and we're going to understand what is lower bound. Okay, round it up to one decimal place. Okay, so what is the upper bound and the lower bound? So let's say that in here in this number line it is 4.5. If it has already been rounded to one decimal place. Okay, this is one decimal place. It has already been rounded up. So what happens that, let's say that we have a number line. Okay, and let's say that if the number was 4.54, you can just say 55. Okay, this means that not including 4.55. Okay, so a number not including 4.55 would be rounded down. Actually I would say rounded down to 4.5. And if a number was 4.45, okay, included, then it will be rounded up to 4.5. So 4.5 is the actual value. This is known as the upper bound, and this is known as the lower bound. Okay, we can write this as in an inequality, which is 4.45 is greater than equal to, x is greater than or equal to 4 less than 4.5. Okay, this is what the inequality tells us, that if a number is not 4.55, then it will be rounded down to 4.5, and if a number was 4.45, then it will be rounded up to 4.5. Okay, and let me give you another example. Suppose that we have a number 450, and we need to round it up, or you can say that it has already been rounded up rounded up to the nearest 10. Find the upper bound and find the lower bound. So it has been rounded up to the nearest 10. Okay, so what we're going to do, how to find the upper bound and lower bound? So divide the degree of accuracy. You can call this the nearest 10, any number, the nearest 100, the nearest 1000. These are known as the degree of accuracy. So we're going to divide the degree of accuracy by 2, making it half. So 10 upon 2 is equal to 0.5. So, 10 upon 2 is 5. Okay, and then in order to find the lower bound, we're going to minus 450 by 5. Okay, and in order to find the upper bound, we're going to plus this 5. Okay, so it's going to be 445, and this is going to be 455. Okay, this is the inequality. And suppose that we have another number which is 5.7 it has one decimal place. What is the upper bound and the lower bound? Okay, so one decimal, the degree of accuracy is 0.1, and divide this by 2 and you will get 0.05. Okay, so lower bound, in order to find the lower bound, we're going to subtract this by 0.05, and now in order to find the upper bound, we're going to add this 0.05. So 5.7, so it's going to be 5.65, and this one is going to be 5.75. So this is the inequality that we have just shown. Okay, this is what lower bound and upper bound means into a specific degree of accuracy. Calculation involving those numbers also give a range of possible answers. Addition between range of accuracy, addition, subtraction, multiplication, division between the degree of accuracy. So doing the addition, you get max multiplied by max. Upper bound multiplied by upper bound is equals to upper bound. Lower bound multiplied by lower bound is equals to lower bound. Okay, subtraction, same thing. Upper bound minus lower bound is equals to upper bound. Lower bound minus upper bound is equals to lower bound. Multiplication Upper bound multiplied by upper bound is equals to upper bound. Lower bound multiplied by lower bound is equals to lower bound. And division. Upper bound divided by lower bound is equal to upper bound. Lower bound divided by upper bound is equals to lower bound. Okay, you just need to write down these four, and then I'm going to show you what does it really mean. I know you guys are confused, so I'm going to do something to do the questions, okay, in order for you guys to understand it. First of all, I want you guys to write it down, these things, these rules, and let me just do it for you, the questions. So question one, so 4 meter long, the string has the length of string, the string is 4 meter long. 4 meter means 400 centimeter, and it is connected to the nearest 10 centimeter, nearest 10, which means this side. So 10 divided by 2 will give 5, and so 400 plus 5 and 400. Okay, sorry, in here minus 5, in here plus 5. Okay, so plus 5, so it's going to be 395. So it's going to be 395, and it's going to be 405. Okay, so we have found the lower bound and the upper bound. Then it says John cuts off 10 pieces of string. Each piece is 5 centimeter long. Correct to the nearest centimeter. Okay, so we have another one that it is 5 centimeter long. Correct to the nearest centimeter, which means nearest to the centimeter 5 centimeter, and it is nearest to the centimeter. So it could be, so 1 divided by 2 is going to be 0.5, and so 5 minus 0.5 and 5 plus 0.5. So it's going to be 4.5, and it's going to be 5.5. Okay, find the minimum possible length of string remaining. Give your answer to centimeter. Okay, find the minimum possible length remaining. John cut off 10 pieces of string, so 10, and each string is 5 centimeter. So 10 multiplied by 5 will give 50. Okay, so it's going to be 45, and it's going to be 55. Okay, and now we need to find what is the possible length or minimum possible length of the string remaining. So if I try to subtract the, I know that since I've been given this range 395 to 405, now it says find the minimum possible length, saying the minimum possible length of the string remaining, and I have to do the subtraction in order to find that. So I'm going to use this one. Minimum minus maximum is equals to minimum. What is minimum? This is the minimum. This one is the minimum, and then minimum minus maximum. And what is the maximum? This is the maximum. So minimum 395 minus maximum is going to be 340. So this is the answer. This is how you actually find the minimum, or you can say lower bound. Find the minimum possible length, or find the lower bound possible length of string remaining, and this is how you use this formula. Okay, question 1 is done. Let's do another question. Let's say question 2, and we have this 33.5 upon 22.0, and we have been given the range of each number. Wait, let's say 33.45, 33.55, and for the 22, 21.95, 22.05. So we have been given the range, and now we have been asked that find the upper and lower bound. Okay, find the upper and lower bound when dividing. So what is the upper and lower bound? Let's say if I want to find the lower bound when dividing, we're going to see this. So in order to find the lower bound, we're going to use this one. So minimum upon maximum. What is the minimum of this number? The minimum of this number is 33.45. So 33.45 upon the maximum of this number is 22.05. So it's going to be 22.05. Okay, and so we will have 1.528 as the lower bound. Now I need to find the upper bound when dividing the number. How to find the upper bound? We're going to use this one. So maximum upon minimum. What is the maximum of this number? The maximum of this number is 33.55. Okay, so 33.55 upon, and what is the minimum of this number? The minimum of this number is 21.95. Okay, so 21.95. Okay, and if you try to divide this, then it's going to be 1.517. So, and also we need to see that each of these numbers has 4 significant figures, but it's fine. So this is the answer. Okay, and topic 7, limit of accuracy, is done. Topic 8, standard deviation. So topic 8, standard deviation. Standard deviation is a way of making very large numbers and very small numbers easy to deal with. Let's say that I have the number 500,000, and I want to know the standard deviation. So how to do that? So they are 50, which means 5 multiplied by 100,000. Then we can write it down like this: 5 multiplied by 10 of power 50. So it's going to be 5. So this is the standard deviation. Let's say that I have the number 43,600. Now I want to know what is the standard deviation of this one. So if I just see it correctly, then if the point goes here, so point is going here, then here, here, here. So 1, 2, 3, 4. So it's 4.36 multiplied by 10 of power 1, 2, 3, 4. Okay, so this is the standard deviation. Okay, so what I really did that if the first of all we always try to see the point. Let's say that I have the number 3, 6, 5, 4, 0, 0, 0, and here is the point. If the point go to the left side, then it will be positive, and if the point go to the right side, then the positive negative the power must be the power will be positive or negative. So if I want to know the standard deviation of this number, so point will go 1, 2, 3, 4, 5, 6. So 3.654 of power 6, and the power is positive. So this is the standard deviation. Okay, and what happens if the number is 0.000003? If I want to know the standard deviation of this number, then the point will go 1, 2, 3, 4, 5, 6. 6 times. So, which means it's going to be like this. Point will be here and 10 of power minus 6. This is the standard deviation. Okay, and obviously you guys must have understood regarding indices, the laws and all that, if having a same base, the power will add up, and if having the same base and the two same bases being multiplied, the power will add up, and if the two same bases being divided, then the power will get subtracted. Okay, good. Okay, let's say that I have the question that I have this question that solve this and find the answer in standard deviation. Okay, so 6 multiplied by 10 of power minus 2. So 3 multiplied by 10 of power 5 upon 6 multiplied by 10 of power minus 2. So it's going to be 3 upon 6 multiplied by 10, 5 minus 2, so it's going to be plus 2. So it's going to be 1 upon 2 multiplied by 10 of power 7. Okay, so I got 0.5 10 of power 7, but this is not in standard deviation. The standard deviation, in order to put this in standard deviation, the decimal point must be next to the non-zero number. Okay, so 5.0. Now this is in standard deviation. So if the point dot will come down here, then it will be subtracted by minus 1, so 10 of power 6. Okay, another question. Let's say that I have this number 5.3 multiplied by 10 of minus 3 and minus 4.9 multiplied by 10 of minus 4. Now after doing the subtraction, I need to find the answer in standard deviation in standard form. So the power is 3 and the power is minus 3 and the power is minus 4. So I'm going to, first of all, we always try to make the same base. The base must be same. Okay, we actually have the same base. How about that I should take the common? Now, in order to take the common, I will convert this in 10 of power minus 3. So 5.3 multiplied by 10 of minus 3 minus 4.9 multiplied by 10 of power minus 3. In order to do that, it will come here. Oh wait, 5 of power minus 3 minus. Okay, as we know that if the dot goes here, then it will be minus. If the dot goes here, then it will be positive. Since we need to 10 minus 4 plus 1, so the dot will go to the left side, so it's going to be 0.49 multiplied by 10 of power minus 3. Okay, then we take the common. 10 of minus 3 multiplied by 5.3 minus 0.49, and so it's going to be 10 of minus 3. This is the standard form, since the dot is next to the non-zero number. Okay, standard deviation topic 8 is done. This is how you do it. Welcome back, and this is topic 9, time, money and measures. So we have two type of hour clock, AM, the 12-hour clock and 24-hour clock. Okay, see, this is 12-hour clock, 24-hour clock. Converting between hours and minutes and hours written as decimal. Okay, write 15.36 hour in hours and minutes to correct to the nearest minute. Okay, so in order to write it down, 15.36 hour in hours and minutes correct to the nearest minute, what we're going to do, since we know that in 1 hour there are 60 minutes, and so in 0.36 hour it's going to be x minutes, so we're going to cross multiply. So 0.36 multiplied by 60 is equals to 21.6 minutes, which means 15.36 hour is equal to 15 hours and 21.6 minutes. Okay, Beijing to Shanghai train travels 1,318 km in 5 hours and 37 minutes. Find the average speed of the train correct to the nearest kilometer per hour. Okay, so we need to find, first of all, we're going to convert the time into hour. So converting 37 minutes into hour. So in 1 hour there's 60 minutes, but in 30 minutes how many hours are there? So we're going to cross multiply, and then we're going to have this 37, and so x is equals to 37 upon 60. And what we will get, I'm using a calculator, I will get 0.62 hours, 0.62 hour. So what it really is, it is 13 upon 8 kilometer per 5.62 hours. Okay, now I'm going to use a calculator, so it's going to be 1318 5.62 hours. So it's going to be 235. It's going to be 235. Okay, kilometer per hour. Time zone. The time of day varies in different countries depending on their longitude. Usually the difference are a whole number of hours. An aircraft. Okay, so we have a question. Leaves Dubai at 08:55 local time and flies to Tokyo. The flight takes 9 hours and 25 minutes. Notice that this is 24-hour clock. Okay, the local time Tokyo is 5 hours ahead of Dubai. What is the local time in Tokyo when the aircraft lands? Okay, so we are going from leave Dubai. So Dubai at 8:55 a.m. flies to Tokyo. Okay, the flight takes 9 hours and 25 minutes. The local time in Tokyo is 5 hours ahead of Dubai. So 5 you do plus 5 and it's going to be 13.55. Then you're going to add 9, so it's going to be 22, and adding 25, so it's going to be, okay, first write it down like this. So 22.55. Now we need to add 25 minutes. Okay, so it's going to be 23. It's going to be 23 20. So 23 hours and 20 minutes. This would be the local time. And currency conversion, exchange rates tell you what one of the units of one currency is equal into the other currency. For example, if the exchange is rate between US dollar and euros, then this is what it is. Each US dollar is worth 0.881, 0.88. Okay. Exchange rate between dollar and euro is this. Sam changes 135 into euros. How much in euros? So we're going to multiply 135 to this. Okay, this is the answer. Then part 2, Franco changes the $34 into 34 euros into dollar. How much in dollar? So in order to change, we're going to do 3340 upon 0.8 in order to convert it to dollars. So that's how it is. Okay, measures: length, area, volume, liquid, mass, time. Starting with length, millimeter to centimeter, then we're going to divide by 1 upon 10, centimeter to meter to 1 upon 100. Okay. Smallest to biggest, we are going to do division, but from going bigger to smallest, we will do multiplication. Okay, so millimeter is smaller than centimeter, and centimeter is smaller than meter, meter is smaller than kilometer. So if millimeter wants to go to centimeter, then it's going to be divided by 1 upon 10. Centimeter to meter, so it's going to be 1 upon 100. Meter to kilometer, so it's going to be 1 upon 1000. If kilometer wants to go back, so multiply by 1000, then multiply by 100, then multiply by 10. And it's the same thing for the rest of it. Length, area and volume. So it's the same thing. Smallest to biggest, biggest to smallest. Second into minutes, minutes to hour, hour to minutes, minute to seconds. Okay, and measure is done. Note, going from bigger to smaller, so multiply. Going from smaller to bigger, divide. Okay, and this is the end of topic 9. So this is the end of topic 9. We understood about length, that going from millimeter to centimeter, centimeter to meter, meter to kilometer, and then going back. In area, if we try to make all the square are areas, so centimeter square, meter square, kilometer square, then going back. Volume, volume, millimeter cube, centimeter cube, meter cube, and kilometer cube. Okay, measures done.